Hello students, Miss Slyman here, and I'm going to talk you through our first lesson of applications of integration. You'll notice that I've made a new question document for you. It's called ABCalc Unit 8 Questions, and you can find it in your student files in the Unit 8 student folder. I was just looking through our the APCalc overview, and so we're entering Unit 8 now, Applications of Integration, and this is our last unit for the course. Well, for the AP part of the course. All right, so here we are with our Unit 8, Lesson 1, average value notes. And so we're going to talk about finding average value of a function using calculus and integration. And we've talked about average value before and how we looked at it as a derivative. Now we're going to look at the average value of a function over an interval. So we remember that when we first learned about calculus, we talked about finding a bunch, integration. We talked about finding a bunch of rectangles to estimate area under a curve, and we called those our left and right Riemann sums. Well, now we want to think about finding a single rectangle to have the same area as the area under the curve. So not just one rectangle that's under the curve, but one rectangle with the same area as the area under the curve. So looking at this parabola here, we're going to try and figure out the area between x equals 0 and x equals 4. So looking at this, I see a rectangle straight away, and I see this rectangle that's underneath the curve, fully underneath the two endpoints. So this rectangle has a base of 4 and a height of 1, so that has an area of 4. For sure, this area is greater than that because, well, it has all of that plus everything above. So it's definitely more than 4. Less than 20, well, if I look at the rectangle that surrounds it, we've got a height of 5, a width of 4. So this rectangle has an area of 20, and certainly our curve is underneath that, so we have all this extra space. So definitely our curve's area is between 4 and 20. All right, so let's try to get a better estimate. Do we think it's more than 8 and less than 16? Well, 8 would be a rectangle that has a width of 4 and a height of 2. So here would be my 8 rectangle. And so definitely our area is greater than 8 because this is the only extra bit, and for sure that is less than this. All right, so let's think about 16. We could put in yet another color. So 16 would be up here. And so now we have a height of 4 and a width of 4. So all of that would be our 16. And now this time we have this bit that's extra. And this is what we're missing. So it looks like our area that we're missing is less than the area that we've gone over. So I think that 16 is an overestimate. And I could try to calculate that. Like this triangle here has a height of 4 and a width of 1. So this has an area of 2. That has an area of 2. So we've gone over by about 4. But this whole rectangle has 4, and we're definitely at half of that. So I would say that this amount is less than this amount. So 16 is an overestimate, 8 is an underestimate. So area is greater than 8, but area is going to be less than 16. So then where should we draw the height so that we find a rectangle that has exactly the same area? Well, I need to draw my height greater than 2, less than 4. So I think that I'm going to put my height maybe somewhere around here, because I want these to have an area that's about 2 together. So right at about 3 would give an area of exactly 2, but I think it's going to be a little bit more. I'm going to go somewhere like here. So this is my magic height value. I'm going to label it as C. We don't know exactly where it is, but let's say that it's at C. All right, so now we've got two methods for area under the curve. Our first method is our integral. So we know that our integral is going to be from 0 to 4. Do we know the function? They have not yet told us the function, so I'll say f of x dx. And then up here, my expression is going to be the area of the rectangle, which is going to be 4 times c, because my width was 4 and my height was c. All right, so if I put these two together, I know that they're representing the same thing. So these two, this in the expression in question 4a, well, I know that they're equal because we set this to equal the area. So 4c is equal to the integral from 0 to 4 f of x dx. And now remember that FRQ that we made you do, that you turned into us, the one that was about fuel consumption? And you ended up with something that was like integral of 1 over b from 0 to b f of x dx, and you told us that it was the average fuel consumption. Well, look at what we found here. If I rearrange this, then c is 1 over 4 integral from 0 to 4 f of x dx. So this is how I can find c, and this is also what we're going to call later the average value of the function. So let's do it. Integral c is 1/4 integral 0 to 4 negative x squared plus 4x plus 1 dx 1/4, and then I'm going to evaluate negative 1/3 x cubed plus 2x squared plus x. I don't need the plus c because it's a definite integral being evaluated from 0 to 4. The 0 I can ignore because when I plug it in, everything will be 0. So I'm going to get 1/4 times negative 1/3 of 4 cubed plus 2 times 4 squared plus 4. And I didn't expand it yet because those 4s are going to cancel. So I'll get negative 1/3 of 16 because one of the 4s is going to cancel. 4 is going to cancel. That's going to give me 8. 4 is going to cancel. That's going to give me 1. So then I've got 9 minus 16 over 3. That's 27 minus 16 is 11 thirds. So there's my c value. This works out to be 3 2/3. And if I come up here, that is pretty close to what I said. I should have gone a little bit higher, but I did pretty well for that. And then in the end, that value of c compared to all the values of the function, well, like I said earlier, connecting that back to the FRQ, this value here is the average value of all the f of x values. So c is the average f of x value from 0 less than or equal to x less than or equal to 4. So let's go ahead and toolkit that. If I'm going to toolkit that, then I'm going to say, so I'll come down here to a new page. So average value of a function f of x on x is an element from a to b. And this could be open or closed interval, doesn't matter. So my average value, I'm going to call it c star to differentiate it from how we normally add plus c. You could also call it some other variable, however you want. This is going to be 1 over the width. So my width is going to be b minus a. In our case, it was 4 because we went from 0 to 4. Integral from a to b, f of x dx. Notice this f of x function, the only thing that we need it to be is we want it doesn't have to be totally concave down like we had up here. That's not necessary. What we do want, though, is we want it to be, let's see here. I'm going to put in some axes. So we could have it look something like this. And then let's see if I'm finding the area of all of this area under the curve and I want a rectangle to match it. So if this was my A and this was my B, well, I only have a little bit of area down here. I have some up there. Definitely it's taller than your lowest value. Maybe I would say that my C star is going to be somewhere around here. So this is where my rectangle would have the same area, and it doesn't have to be that midpoint or that end point there. That just happened to be where I put it. So we're saying this rectangle has the same area as this shaded bit underneath. And I would also say that C is the average value of f of x. And something else that you could be asked is how many times f of x is equal to its average value. The way that I've drawn it, we would say 3. We could find those 3 points of intersection by setting C star equal to f of x. And so a question for you to consider is, will C star always intersect f of x? So something for you to think about. And if you can't figure out the answer, something for you to ask us about. All right, so that's your lesson 58 video. Go back and try the CYUs. Check your answers on the solutions document. And when you have questions, please post them on your Unit 8 questions document. See you soon.